Fractions have always been a headache in school. And in high school, they're still a nightmare. Fractions, decimals, and percentages. This is a prototype. There's no use to do 500. The prototype is this question. What fraction is this of that? And because it's a fraction, I write it. It looks like a fraction. What fraction is 24 centimeters of a meter? We cannot compare centimeters and meters. It's silly to put 0.24 meter, that's silly. So we leave the centimeters and we turn the meter in 100. And we go back to our recipe. Time and time again, it is the recipe that starts you off, not the thinking. The thinking stops you. The recipe starts. Of course, you have to remember the recipe. What fraction is this of that? Now, here, what fraction is this of that? That's it. And then the first lesson is we learned about odd and even numbers. Even numbers, you can always halve them. I didn't mind if you say 12 on 50 and 6 on 25. But if you're a bit quick, you say, there is a 4 in 24 and a 4 in, okay. What fraction is 4 weeks of a year? Aha! In professional memory training, you learn that if you want to remember something, you have to first say, I want to remember this. I want to remember this recipe. The second question is, how can I remember? And so in this particular case, well, you know that a meter is 100 centimeters, but now, you have to turn this into weeks. You either know or you don't. If you don't, I'll give you a way to remember it. I must admit that I hate counting fingers. When I used to teach the 9 times table, people invariably come with their hands and their fingers because the teacher has something magic. Well, it is not magic. It is ridiculous. Think one lesson apart now. To remember how many weeks there are in a year, I give you something to remember it by, and that is in Greek a mnemonic. It starts with a silent M, so it's a difficult word. A mnemonic is anything that reminds you. Of course, two hands. 5 fingers, 2 hands, 52. Let us repeat that. A year. 5 fingers and 2 hands. 5, 2. So this is 4 on 52, which is 1 on 13. Here again we have to turn the kilogram into 1,000. So it is actually 450 on 1,000. But of course we cancel the naught straight away, so our first number is 45 on 100. And again, is there a number that goes in both of them? Of course. Think one less than the partner. 9. They add up to 9. 1, 8, 3, 6, 2, 7, 4, 5, 9. How many 5s in 120? What fraction is this of that? Recurring fractions. No, recurring decimals, sorry. Recurring means occurring again. Means again. Recurring, that means occurring again. I don't know why they have left out the oc, but recurring. If the calculator shows this with a dot, that means there's no end to the 6's. A dot and 1 8 and 2 dots, then the 18 repeats itself. I don't see why decimals are so difficult. 2 whole numbers. We have already went from fractions to decimals. So this is 2 whole numbers, and this part is less than 1. That we split them up in a whole number and a decimal point. And if we times this number by 10, that means the decimal point moves 1 to the right. Because if you multiply by 10, it gets bigger, it doesn't get smaller. So it is 23 times 4. How can that be difficult? 100 times point, so this is less than 1. Same recipe, count the number of noughts, and then the decimal point goes here. Of course, the teacher in school has taught the children to 1 and 2, what an insane habit. The decimal point doesn't jump. 1, 2. Why should you do this silly dumping? And all kids do it. They all jump 1, 2, and they all write back to front. Ta, ta, and ta. But I'm not going this way, I'm going this way. Right down in the round, and because you're in the round, you actually multiply by 1,000. That means the decimal point moves 1, 2, 3 places. Forget about your jumping. Now we have only one number to move. So this is only 1 nought. And because I'm running out of numbers, I have to still do 2 places, and that is 2 noughts. One, 2, 3. How on earth can it... Yeah, if you talk about it for 5 years, then you forget. And of course, if you do multiplication, we do And if multiplication is to the right, if you divide something it gets smaller, so we go to the left. This is 234 divided by 10. Aha! And you put this number in the calculator puts a decimal point here. In an ordinary working page, that's insane to do it. So we have to think the decimal point at the end, and we move it 1 to the left, 23.4. Division, we go to the left, 2 points. We have to think the decimal point here, and we move it 2, so it's 2.34. The same as before. We have to go 4 places to the left. The decimal point you have to think here. 1, 2, 3. You run out of numbers, so it is a naught. 0.034. And of course you don't write, so you don't write that naught anymore. There's only people who went to school. How many times did we do algorithms? For addition, for subtraction, for multiplication, division. This is so simple. If you add these two numbers, you have to make sure that the decimal point lines up. Your I says 9, your I says 8. The point, repeat. Your eyes, if you add 2, an odd even number, you get the even. If you add 1 to a number, this is the whole theory of numeracy. If you add 1 to a number, you get the next number. If you add 1 to a number, you get the next number. If you add 2 to an even, you get the next even. If you have 1 to the next. This is lesson 1. Aha! Multiplication. So we act we start with forgetting this. We put here the decimal point as we come to it. Multiplication, we put the decimal point at the very end. So we ignore anything times naught is naught. So we do 10, put down the naught, carry the 1, and 8 is 9, 6, nothing to carry, 4, 2. They each have a turn. We learned that 3 lessons ago. But that's not the answer, because it is not times 2, it is 2000s. So we're putting in the decimal point last, and we have to count 1, 2, 3, 4, 5, 6. We imagine the point to be here, and we don't do silly jumps. That's only in school. Here, 1, 2, 3, 4. I'm running out of numbers. Well, then you put a naught, and now the decimal point. So you have done 1, 2, 3, 4, 5 point. And nobody says anything, because I've only done 5 points. Nah, I have left the naught out. So we must not look at this. We must look at this. 1, 2, 3, 4, 5. I'm running out of numbers. Put a naught and then the point. So it is not 5, because It's silly to put this note. Order of operation. If you work with your calculator, you don't have to think, you just do in order of the calculator. But if you do it manually, we have to do the following instructions. There is a set of rules. It's called the order of operation. We do the brackets first. There is about 3 types. This is actually only brackets, parentheses. And if you've done this, anything in between, so this first and then that, then you do times and division from left to right. And only then do you do the positives and the negatives. Well, that is difficult in primary school because you've only learned of plus and take away. So you don't know what this means. There are only 2 numbers, positives and negatives. There's no such thing as takeaway except for a hamburger. No onions, no beetroot. So those are instructions. Now we're going to apply these rules. No brackets. There's only positives and negatives, so we're going from left to right. The first one, if there is nothing there, it is positive. So that is again shorthand. So it reads actually positive 8, positive 9, negative 13. So there is 17 positives, no plus and take away, and there is 13 negatives. I say it for primary school kids. The positives are winning by 4. They like that expression. Positives and negatives, so that's your own sum. There's 12 positives and 13 negatives. The negatives winning by 1, negative 1. There's positives and division. We have to do the division first. 15 divided by 3 is 5 and 13 is 18. Division first, 3 and 6 is 9. Multiplication first, 20 take 12 is 8. 24 take 14 is 10. Bracket, parentheses, we have to do this first. This is 2. And then multiplication first, 10 twos is 20 and 6 is 26. Don't go and work this out. I use maths to practice the techniques in professional memory training. For me, maths comes last. Your brain and your education comes first. A good eye doesn't do 5 times 81 of the nah. Oh, that's funny. 81 fives and 19 fives. That's 100 fives, that's 500. See, that's intelligence. And what does the school does? Show the necessary working. It's not necessary at all. It's a question of seeing. 100 fives and 19 fives. But if you go to school, of course, you didn't see that. When we have times and division, we have to consider the signs. There's only one rule, not 3 and 4 like in school, no. If the signs are the same, it's positive. You can see it. One negative and the other one this way, and it is a positive. But that's only a little trick. Step 1. Decide the signs are the same, positive. And then 24 divided by 8 is, of course, 8 3s are 24. One on the left, one on the right, 3. This is 4. Multiplication for 20 and 27. Here again, not 4 times 75 is down. Nah, you have seen that, hey, 75 fourths and 25 fourths, so we have 100 fourths, that's 400. Signs are the same, answer is positive. Then we do 21 by 7 is 3. Calculator in the order given. But in primary school you're not supposed to. And I never understand if children cannot handle it, why they're not given a calculator. Adults do, bank tellers do, so why not children? Nah, you have to be in 2nd grade. I think I should have done this first. But I'm getting older, so I make not mistake, errors. I forget things. No signs in front, so it's positive. So the signs are the same. 80 and 20 is 100. Signs are different. That's your first step. You have to see the signs are different. So you start with negative. And 425 is in 100. You see that the signs are the same, not afterwards, before. And you don't write the positive, and that's 100. Negative, different signs, negative, 3. Signs the same, positive, 7. Times and division from left to right. But we can already do that we have only one negative and the rest is positive. So we start with, the signs are different, so it's negative. 36 divided by 6 is 6. No wonder my course is called Maths in Minutes. Now I said fractions is like a headache. Percentage is like a migraine. As soon as people hear percent, they switched off. They're dead scared of this thing. Percent, this is 100. 100 means 100. So this is a fancy way of saying per 100. You know, we live in an age of pictures, pictorial age. Everything has a symbol. I think this is the simplest symbol I can imagine. This is the symbol for 100. 1 and 2 noughts. It is absolutely superb. And now when you work with decimals, with percentages, you don't put it, far too complicated to put it in the calculator. You learn to convert percentage into decimal. So can you see this looks already much comfortable than this? Only one dot left. Now the recipe. Because 5% is 0.05. How did I get it? Now, this sum is in the course the discovery methods. So this is the example. Hey, 5 becomes 0.05. So 6 becomes 0.06. And it doesn't matter if you don't know, because it's in the answer at the back of the book. But if you don't know it, you better listen to my lessons. Because during my lessons, I give you the recipe. What have I done? 5. If I write 5, the decimal point is not written in the calculator, it's the back. And we have to go 2 places to the left. 1, 2. 1, 2. This thing tells you what to do. You have to go 2 places to the left. 12%. 2 places to the left. 1, 2. Decimal point is here. 2 places to the left. 1, 2. 0.13. 2 places to the left. 1, 2. 1 point. The decimal point is here. 2 places to the left. 2.34. It is easier and more sensible to work with decimals than with percentages in the calculator. And of course we start, this course is about seeing. So these are the easy ones, ending in noughts. Of means times. We don't write it, but the calculator decimal point here. And we go 2 places to the left. 1, 2, so it's 2. So it's 6 times 2 is 12. But of course, eventually you don't even see, you see percentage, you see 2 noughts, 6 2's 12. Automatically you take the 2 noughts off and it's 12 times 70 is 840. Here the noughts is on one side, 1 nought here, 1 nought there, so 2 6's is 12. Has nothing to do with understanding. Of is times. 6 times an even number is half the number, and so we have done that before. There's nothing new. All you have to say, mentally I do 2 noughts off, 2 noughts off, 2 noughts off, so it's 6 2's, 12. But in general, it is not always so smooth as this. 24% of 85. The decimal point is here. I prefer to change the percentage into decimal. We have done that 1 minute before. Decimal point is here, 2 places to the left. So instead of writing 24%, I write 0.24 and this number stays the same. So rather 2 places back in here, but it doesn't matter. But it is better to have one system. 24% is 2.24. 12% is 0.12. My daughter is 60 and she asked me the other day, Dad, she's a nurse and the whole department talks about payable hours and you name it. It's so complex. She said, Dad, I get a headache. I said, what's the problem? She said, I have to work out what percentage is this of that. I gave her my book. So again, I write it as a fraction. As a fraction is this of that. As a percentage, what percentage is this of that? 2 places back, 2 places to the left. And then it is just calculator work. What percentage is 34 of 1700? 2 places back. Two. So it becomes 34 on 17, 2 places back. 34 on 17. 34 on 17. Before we had 6% off, that meant times. But this off is outside this fraction. So it's not times. So it is a bit confusing. For the first time in 40 years, I can see that. So the best thing is, if you see this, you straight away write it 34 of 1700, 2 places back. So 34 on 17 is 2. So you write 54 on 80, but 2 places back. So that's 44 divided by 0.8. This is 2000. So 2 places back, so it becomes 20. So it's 460 on 20. Well, of course, that's 46 on 2. 23%. One recipe for the next of your life. What percentage is this of that? That is for the next lesson, maybe in half an hour. Because I have to have a drink. This is like algebra, of course.